we're live. Have fun, everyone.
Thank you and welcome to another Boundary Deep Dive session. I guess I'm going to be your host, Rob Barnes, aka DevOps Rob. Thank you very much for joining us. We have two very special guests in the building today, the Jeffs, we're going to call them. We are missing Pete today, and you're normally used to seeing Jeff, and Pete with myself, but I'm sure these two fantastic guests will more than make up for Pete's absence on this one occasion only. Don't make it a habit, Pete. So let's introduce the first Jeff. So we'll start with Jeff Malnick. If you can just say a quick hi and just tell the people what it is you do.
How's it going? Jeff Malnick, I'm the engineering manager for the Boundary project.
Thank you so much. And the second Jeff?
I'm Jeff Mitchell. I'm the engineering lead for Boundary.
Thank you so much. So I believe this is AWS reInvent week. So this is a bit of an AWS theme. But before we kind of get into that, I'm going to assume there are some people that are attending this conference that maybe have never heard of Boundary. So I kind of wanted to start with some basic 101, the kind of problems that Boundary is designed to solve. So we'll probably kick that off with Jeff Mitchell. So if you can give us kind of like an overview of what Boundary is and the problems it solves, sort of how it goes about doing that.
Sure. So Boundary is looking to solve issues related to secure access to network resources. And there are lots and lots and lots of ways you can do this. There's firewalls, there's VPNs, there's all sorts of things. What Boundary does is it sort of combines a couple of useful things. So one is identity. And in the current iteration of Boundary 0.1, right now we have kind of its own built-in database of users and passwords. But in 0.2, we're going to be adding OIDC support, which will let it connect to pretty much every directory out there. So one is using your identity and then tying that to just-in-time authentication of network streams. And so, rather than say, I want a VPN onto my employer's network and then access, tons and tons of machines, then it says, okay, every time that you want to make a connection to a machine, you don't have to VPN in and like sit on a corporate network, but you do need to have that particular network connection authorized and authenticated. And we have a very long roadmap, which will add all sorts of fun things to that. So the ability to do protocol decoding and to add a lot of things you can do, such as credential injection. We're not there yet, but that's very much on the near-term roadmap. All the way out to things like controlling what kinds of commands might be able to be run inside of a session, and potentially archival of sessions.
Amazing. You mentioned something in there, which we've had this conversation many times, but I'm going to assume there are going to be people out there that had the same question I had. But what exactly is protocol decoding?
Sure. So right now what Boundary does is it says, okay, you want to make just a generic TCP stream. So any protocol that runs over TCP, be like gRPC, HTTP, SSH, anything like that, we can proxy. So we can say, okay, you want to make a TCP connection, whatever it is, we will decide whether or not that TCP connection is allowed to be made, and then connect you through to the endpoint if it's authorized. What we're going to get to is a point where we can say, okay, it's not just a TCP connection, it's actually an SSH connection. And so we can basically, in the security world, you say man in the middle, and usually that's a bad thing, but in this case, it's a good thing because we would man in the middle of that connection. And that would allow us to do things like inject credentials. And so one of the really nice things about doing that is if you're doing credential injection, you can say, all right, the end user isn't using credentials that they have access to. In fact, they never see credentials outside of their Boundary credentials. Instead, what we do is every time that we want to connect to the end host, we're injecting credentials that the user never sees. And one of the really nice things about that is that way, if someone manages to, let's say, get a hold of a user's, Boundary token, let's say, they can use that to make connections through Boundary. But like once that's discovered, once you kind of discover the intrusion and revoke those credentials, they're cut off. If they manage to get onto the network, they still can't make connections to that machine, right? So you're sort of removing the ability to sort of sidestep controls by just being on a network. And that's actually a really important reason why we think the solution is better than like traditional VPNs, which is, it's not just enough to have potentially like I have a set of credentials for a machine and I'm on the network. It's like you actually don't have those credentials. And so even if you get on the network, if you get around that security device, you still can't make that connection. And there are a lot of, this is, I think popularly Beyond Corp, like this is a model that Google has written fairly extensively about. It's a model that's actually much older than that, but that's kind of the kind of popularization of this approach. So if you've heard things about like Beyond Corp style security, that's pretty much what this approach is.
Okay, I appreciate the explanation of that underlying thing. So give me one moment. Right. So the other thing I wanted to ask you about is if I'll take it back to the Vault days, right? So when Vault first came out and we discovered this secrets management problem, it was something that we didn't know even existed. We had this problem and, we didn't even know it was a problem. So in terms of Boundary and the kind of problems that it's solving, how do we know, what are the symptoms that we are actually going through this problem that Boundary can solve? What are the kind of things that we can look out for to identify that?
That's a really interesting question. So one thing I'll say sort of up front is that, a lot of people are wondering sort of what's the difference between Boundary and Vault? Like why would I use one or the other or both? And one of the things that we found from a lot of experience of building Vault, which is, a very successful platform for kind of dealing with secrets and encryption and other sorts of security related fundamentals, is that Vault is really good for computers. It's really good for, it's API first, which is familiar to anyone using HashiCorp products. But it's really directed at being able to handle huge amounts of secret generation and revocation, access, encryption as a service, all the things that Vault can do is designed to do at very large scale. And so it's really optimized for kind of API and sort of application driven access. Where people really have a lot of problems with it are the human aspect. And there you actually see you see people saying, I want to have a better way to have human-oriented workflows, which isn't to say that you can't have human-oriented workflows with Vault, or that you can't have machine-oriented workflows with Boundary. But the common case is that, I have users that are developers on their home machines, or they are users in a NOC, people that maybe you trust, but you don't necessarily trust completely and fully on production machines because you have, PCI and SOX compliance and auditing requirements and all sorts of things that you need to deal with. And so, so for the human-oriented sort of workflows, what you really want to do is you want to sort of provide them a way to connect with tools that they already have and that they're used to using, and then sort of get out of the way. And so the challenge there is enhancing security while not interrupting the workflows. And so one of the things that Boundary does is, previously you could say, all right, I want to get SSH credentials from Vault. And then I, as the user, I'm responsible for saving those credentials somewhere and then telling SSH to use those credentials and then making that connection. And what we're trying to do with Boundary is make it really easy where you can say, okay, I'm just using the Boundary client to say, I want to connect here. And it's taking care of, through an integration with Vault, of generating new credentials, of injecting those into the stream, of giving you the credentials you need to actually make the connection to the Boundary worker that does the proxying, but hiding all of that from you. So instead, what happens is we launch SSH. You're none the wiser. We just launch SSH with the parameters that you want, and all that authentication is taken care of for you. So I think that's, I think when you're looking at sort of what are the things that Boundary's tackling, especially as it compares to Vault and kind of the experience we've had there, it's really the human-oriented workflows. Now, we have had customers that say, I want to slot this in for machine-to-machine access, and you can do it. Right now it's really, really early. We don't sort of have a very programmatic way, but if you can fork and exec the Boundary CLI, then you can totally do that. And that's something that we'll be investigating kind of as time goes on, either kind of solidifying the protocol or seeing if there are ways to make it very machine friendly. But at the moment, it's really, we're trying to sort of tackle that aspect of security that the Vault is sort of well suited for dealing with the credential generation and sort of the secrets aspect of, but not really for the workflows involved.
I think that brings me to a perfect segue to hear a little bit more from Jeff Malnick. So you talked about workers, which kind of opens up the opportunity to start talking about some of the components here. So my question to you, Jeff Malnick, is what are some of the components involved in a Boundary deployment? And I'm basing this on the fact that you've done a reference architecture. So can you walk us through what that looks like, please?
I will say,
Sure.
I will say, you called him the first Jeff before, and I feel like you drew a line in the sand there, and like you should just continue to call him the first Jeff.
Jeff number one, but everyone's a number one.
Technically, I'm the second Jeff at HashiCorp, I think, so, or at least on Boundary. So there's a couple of pieces of the reference architecture we can talk about. So for Boundary, there's the concept of workers and controllers. So we've broken down the architecture of Boundary itself into these two stateless services, plus a Postgres database. So we handle all of the state inside of Postgres. It makes it so we can scale controllers and workers independently of our data system. So the control plane is obviously where the controllers come in. If you want to fork a session, Boundary connect SSH some target, that command actually runs through the controller first, and then the session is established via the worker. So what that means is that as you scale up the number of clients, they're interacting with those controllers to get information about running sessions, start running sessions through workers, that sort of thing. That system can independently scale outside of the worker infrastructure, which is actually handling the sessions. So let's say you have like tens of thousands of sessions, and you need to scale up workers. You can do that independently of the control plane, which makes Boundary a highly scalable piece of architecture. So if you look at our reference architecture, and Rob, you can share that link in the live stream chat. We've got a good diagram there that shows how to get Boundary going on AWS. Now, I want to disclaim that the reference architecture we have is purely for example purposes. It's not meant to be a production-ready type of architecture. This is really meant to get you up and running on a cloud platform quickly. There's also an example of running Boundary via Docker Compose. So I think with the two architectures that we have in there, the Docker use case with Compose and the AWS use case, it lays out how we would expect the basic Boundary deployment to go. So in the reference architecture, you'll notice that we have an AWS VPC. That VPC is broken down with two subnets, a public and a private one. The private subnet contains the targets that you're trying to access, and the public subnet contains the controllers and workers, and it also contains a load balancer that proxies the controllers. So that load balancer is just doing round robin proxying to the controllers. When a client connects to it, it gets a random controller, it doesn't matter which one, and it starts a session and it goes through the worker and then to the target in the private subnet. So that example use case there is showing how somebody on a public internet can go through Boundary, essentially using Boundary as like it's a VPN on steroids in this case, full identity and access management solution built in, and they're accessing a private target. There's people that have been playing around with this, have done all sorts of things. They've accessed the Postgres database that's running on RDS through this infrastructure as well. That's kind of the basic layout of Boundary. Now, if you don't need to access Boundary through from a public-facing client, you can always deploy those controllers and workers in private subnets and just use Boundary to gate access to different private resources. Maybe you have like a DMZ within your intranet, within your corporate network that you want to use Boundary to gate access to. You can do that too. In this example, though, we're obviously the client's going to be public because we're on a public cloud. So they're going through a public-facing load balancer into a public subnet and then into the private subnet.
And in terms of the targets that are in the private subnet, could these be anything? Could it be containers? Could it be VMs? Literally anything? Maybe another RDS database?
Yeah, they can be anything. In the AWS reference architecture, we provision we look for an SSH key that you give the Terraform provider that provisions Boundary. That's the other cool thing, by the way, about the reference architecture. It's a great example of using Terraform to provision Boundary. So it actually provisions the AWS infrastructure for you and then takes a bunch of outputs from that AWS deployment and pumps those into the Boundary deployment to configure everything like where the targets are running and that sort of thing. So it's a really cool example of doing that. But yeah, the targets themselves in the reference architecture, we're just doing a simple SSH target. So we're putting we're putting a key over on the VM, the EC2 instance running in a private subnet, and then you're accessing that VM through Boundary. But it could be, you could set up Kubernetes in that private subnet, have the Kubernetes control plane be accessed through Boundary, or have, kube exec go through Boundary as well. It's really the possibilities are endless there.
And one thing I want to just, can I add one thing to that?
Yeah, sure.
What I wanted to add is simply that, as I said before, right now, our target type is TCP. And so when we say things like, Boundary Connect SSH or an SSH target, what we really mean right now is TCP. When we get to protocol decoding in the future, we'll have different target types. But the reason I really want to point that out is, right now, anything that you can run over TCP, you can technically run through Boundary, right? Like when we say things like Boundary Connect SSH or Boundary Connect Postgres, that is the CLI command that just makes it easy for us to do things like start your SSH client for you. But you can simply make a TCP connection and then execute anything that you want against it, either via our command or by just having our command running in the background and then connecting through that listener that it creates. So it's just sort of it's an important point in that it's not, a lot of people have looked at sort of the CLI and said, you have SSH and Postgres and RDP and something else, and so like that's all the Boundary supports, and that's not actually really the case. We support anything that you could want to exec through TCP at the moment.
Yeah, to follow on with that, there's actually a great example we're working on that uses the proxy command configuration inside your SSH daemon. So you don't technically even have to run the Boundary Connect command yourself. You can just have SSH execute Boundary Connect in the background as a proxy command, and then have SSH run through Boundary, which is really cool, right? Because now all you're just doing is interacting with the native SSH command.
So when we think about it, if we just simplify everything, all we're doing is providing an authorized proxy session to the target. It's really not much more complicated than that. That's kind of the be all end all of it, kind of, right?
Yeah, it's not more complicated, but the devil's in all the details, right? It's making sure that you can sort of describe those and set them up and figure out how to gate access to other things you've described. Like a lot of what Boundary does is in its entirety, the entirety of sort of its data model. And outside of that, the actual carrying of the bits is not that complicated, at least at this point with pure TCP.
Looking through the reference architecture, there's a few TLS components within I'm going to call it the cluster, right? Are you able to kind of walk us through their role there? Like what exactly is it securing? What communications between what components is that kind of protecting?
Yeah, so there's a couple of pieces that are actually happening there. So the first is, actually, let me pull up the reference architecture just so I give you all the correct information here, because so there's a couple of pieces that are actually interacting with Boundary here. So the first is for TLS, we're using Certificate Manager on AWS. So we're grabbing basically a self-signed certificate from Cert Manager, and we're using that to do TLS on top of the controller and the workers. So everything is going to be TLS enabled there. The second thing that we interact with is AWS's KMS service, and we're using that for key management. Now you can do like an AEAD key manually. You can just put it into the Boundary configuration. But in this example, since we're on AWS, we just generate a key inside of AWS's KMS, and then we use that to secure and bootstrap the cluster. And we actually use that key as well to have the Terraform provider run in what we call a recovery mode to set up Boundary without any extra steps. So it's actually using AWS's KMS, the Terraform provider is, to authenticate with the Boundary controller and start provisioning resources. We do that simply so we don't have to go through the process of setting up users and groups for Terraform to actually access Boundary. We're just coming in as like a root user per se. It's just for ease of use in this example. So those are the two main services that we're interacting with there on AWS to secure the Boundary cluster.
Amazing. Before we move on, I believe we have a question from the audience. So it says go to public when static IP with, well, I'm going to imagine they mean with. So go to public with static IP and port only, right? That's the question. So I'm guessing they're asking about the connectivity.
Yeah, I asked for some clarification, but I'll take a guess at what was meant and sort of go based on that. I think what was being asked is, can the target that you're connecting to, from when you have the worker in the middle proxying and you have the client that's connecting to the worker and the worker's connecting to something else, does it have to be a static IP and port? And the answer is no. It's anything that we can make a connection to, via essentially the OS, right? And so, it can be something that requires a DNS lookup, so it can be a host name. Right now, because it's a TCP connection, then it does require a, you configure the port as part of the target configuration, and we always use that port. But that's a part of the addressing for TCP. We might get to a point where we can do serve lookups. We haven't really done that yet, but it's something we are thinking about. But the other thing is that we're thinking about, or not even thinking about, but we are actively going to do, are host catalogs that source data from elsewhere. And so, right now you can use Terraform, or manually you can add in hosts, and you group those into host sets, and then you say, okay, my target is going to connect to these hosts via this host set on this port. And that's fine, but it's all kind of very statically done. And one of the nice things about that particular catalog is just, if you are setting it up through Terraform, as you change other things in your Terraform config, you can have that automatically updated. So there's real utility for that if you're a Terraform user. On the other hand, not everyone's a Terraform user, right? So we plan to have other mechanisms such as like the various cloud instances like EC2, Kubernetes, Console, things like that, where you can say, okay, so for instance, Console is a service catalog, service discovery. And so you can say, hey, Console, I want you to sort of automatically create host sets for me based on which, on hosts that are advertising a particular service. And so because Console allows those hosts to advertise those services on different ports, then we would also, as part of that definition for that endpoint, bring in the port that's defined for that host. So we have a lot more dynamism coming. It's just that right now, because it's at a bare TCP level, then it does have to, it is a static port, but it can be a DNS name.
On that, I'm going to guess here that you could actually just manually input a console service name into that host catalog, though it's not populated dynamically. So if you have all of your services registering to console, and they're dynamic services, so the IP addresses and the ports are forever evolving, you just want to refer to it through the name that console is giving it, right? So let's just say,
correct,
for argument's sake, database.console.
You could do that with one caveat, which is that right now for like the static addressing service, we don't support per host ports, at least not at the moment. So you define the port at the target layer, because the idea is that as a target, you're defining a service you want to connect to, and that service might be sourced from something else, like a console catalog or like a filter running on EC2 machines, but you're defining sort of a logical service. And so we define a default port in the target, and it's called default for a reason, because we expect it to be able to be overridden by other services. But at the moment, with the static host catalog, we just do a host name. We don't allow overriding per port. And part of the reason for that is that, this is something, when you're talking about a static host catalog, that is a host that can potentially be used in many different host sets, which group hosts together, and therefore many different targets. And so if you have a fixed port there, it'll be very hard to distinguish like what port do you actually want to use. That's why we haven't gone down that path yet. But it can be a console name. So assuming that all the services within console that are exposing that particular service have the same port, then you can definitely do that. So and the only requirement there would be what you would expect with console, which is the worker node or the worker's DNS would have to be set up to use console for DNS resolution.
Amazing. Kind of going back to the reference architecture a little bit, there was one question that I didn't get to ask that I wanted to put out there. So it's actually two questions, which I kind of think you half answered it. So the code that you have in the reference architecture, the Terraform code, is that published on the Terraform module registry, or is it purely just for reference purposes? So there's just no intention of publishing that? That's
the provider's actually, so the provider is available on the Terraform registry for download today. I'll put a link for that in the chat.
And how about the, I don't even know if, I guess technically speaking, it's a module, that the code that you've written for the reference architecture. But is it published as a module, I guess is the question.
It's not, no. We have plans to do something like that in the near future, but haven't actually executed on it just yet.
Okay, amazing. And the next question is, for someone who wants to play around with Boundary and get started, is this the place to start, or is there something else that's probably a better fit to play around with it?
I think for getting started, we have a really good getting started guide that will get you up and running with the dev server on our docs page, and that's really the best place to start. The reference architecture is for a semi-advanced user, somebody who has already done the getting started, already has taken Boundary for a test drive in dev mode locally and wants to now get going on top of cloud platform or some kind of other platform, and just needs a good idea of like, okay, how should the networking operate here? What are the caveats with, what ports I need to have opened? How do things actually interact with Boundary in a real running environment?
Amazing. So staying on the reference architecture, but shifting gears a little bit, another thing that I noticed within that repo is it goes beyond just infrastructure. Like you mentioned, there is actually the Boundary Terraform provider available to use today, right? And there is some code written there that sets up some Boundary components in there. So go into, what do I call you? Jeff number 2? Jeff Mitchell. Can you walk us through the Boundary components that are in that reference architecture, please?
Now it'd be my turn to pull it up. I actually, to be honest, I'm going to send it back to Malnick because he did the lion's share of work on the provider, and I think he's also a bit more AWS knowledgeable than I am, actually quite a bit. So I'm going to send it back his way.
Jeff number 1.
So there's a couple of different components going on in there. So there's the Boundary components, there's the AWS components. So on the AWS side, we've got obviously the load balancer I already referred to, the different services we interact with on top of AWS. So we are running Postgres, I think 12 on RDS in this example. We've got a number of security groups that are restricting access to that Postgres database to only be coming from the controllers and workers. The 2 separate subnets, I think we're running in 3 availability zones in each subnet. So it's actually scaled across a couple of data centers. We're interacting with AWS's KMS for the worker authentication key, the root key, and the recovery key. And obviously those keys are then also accessed by the Terraform provider when it goes to provision Boundary once it's up and running. And then obviously EC2 for running the controllers and workers. Now in this example, I want to point out that we're running controllers and workers on separate EC2 instances. I think in the diagram, I said that they're in an auto-scaling group. They're actually not in an auto-scaling group. Full disclosure there. They should be, ideally. So some kind of self-healing mechanism should occur there. They're not in this example yet. We're interacting with ACM, so the certificate manager, to actually do TLS between the different servers. And let's see here, what else? Oh yeah, so the controllers and workers are on separate EC2 instances. You can actually just run them on individual EC2 instances if you want. So you can run the controller and worker all in one host in one process. And that is, if you have concerns about cost or something like that, and you just want to take this for a test drive, that's a pretty easy modification of the Boundary configuration file in the AWS module. So feel free to fork it and, modify at will there. Yeah, these are all things that Rob, you alluded to with having like a Terraform module. These are all things that we would want to make configurable and pluggable from a module abstraction. There's quite a bit there. It's a very sophisticated, it'd be probably a fairly sophisticated module that we would build there for that.
Amazing. And in terms of Boundary itself, so I've full disclosure, I've written a blog article which kind of takes you through the IAM structure of Boundary. Within that reference architecture, I think there are some Boundary components. So you have like organizations and projects. Are you able to walk us through like some of these kind of lower level pieces?
Yes. Okay, so there's a lot of, there's quite a bit of boundary configuration here. So let's start out with the scopes level, because Rob, I think your blog post actually spoke to scopes quite a bit, and it's the first boundary resource that we actually have to interact with.
Can
So
I interject one thing here real quick?
Yeah, please.
What I want to say is that, Malnick's going to walk through, by the way, I'm calling him Malnick because on the team with two Jeff M's, like we just use each other's last names. There's no other way. So I'm just used to it. But he's going to walk through it. One thing I want to say is like, it may seem kind of daunting at first that there are these multiple layers there. But as he was saying before about kind of the goal of scaling to very large sites, a lot of this is really about how do you organize information. And so he'll talk about like what the intention is for the various types of scopes, but really we sort of built it with this idea and plan that it is ready. It may seem like you have to do a bit more boilerplate when you're small, but when you get big, it's ready to go and it'll still work. So just wanted to preface sort of going into those scopes with kind of getting into the right mindset to understand what it's all about.
Yeah, thanks, Jeff. So on the scope side of thing, we're defining one scope and we're taking over the management of another one. So boundary and the Terraform configuration in this case actually takes over the management of the global scope. And then it's also generating an organization scope and a project scope. So a organization lives under global and then project lives under org. And you can have multiple orgs and projects within Boundary. For this example, we're just defining one of each. After we define all the scopes, we define some principles, and principles can be either users or groups. And so in this case, we're actually defining quite a few users. So we're defining a backend user, a front-end user, and a leadership user. So when we made this example, we actually took the names of the people on the team and all the other people who interacted with developing the Boundary project cross-functionally and kind of added them to these various groups. So the backend and front-end groups both have administrative access to the projects, and the leadership group only has read-only access because that's what leadership gets, is read-only. So if you look at our principles.tf file, you'll see these users getting created, and then we're actually doing a for each statement on a variable for the leadership backend and front-end team for each different user. And then we're just iterating over those users and creating a bunch of users. So I think there's like 30 something users once we're done with this. We then go through and make accounts for those users, and we associate the user with the account, and that's for the password auth method. That way the password auth method account is assigned to a specific user within Boundary. So now that user can log into Boundary itself. And then we also go through the process of creating 3 separate groups for front end, back end, and leadership, and we use those groups as grouping methodologies for all these principles. Then we go through and we create a bunch of roles. So there's a couple of roles that in this example, we're not generating. So there's in Boundary, if you don't specify to, when you create a role, that this role could actually manage the scope. I'm sorry, when you're creating a scope, you can tell Boundary, I would like to make a role automatically that can manage the scope that I'm creating and add this user to it. Now, in this example, we're not doing that. We're actually going through the process of creating the roles independently just to show that you can manage everything in Terraform. You don't have to, but in this example, we go through the process of doing that to kind of take drop the curtain on what's going on under the hood. So in this example, we actually create a role for anonymous listing at the global level. And so anonymous users can actually list the global scope. Anonymous users can list the org scope. And so those two roles in particular are just applied to the anonymous user. It's a built-in user. Anybody that's not authenticated to Boundary are acting as the anonymous user. And this allows them to list scopes when they go to the login screen so they can actually get a login window and log themselves in.
And anybody that is logged in, just to add that. It's not exclusive because there is a UAuth as well, which is only users that are authenticated via a token. So it's a superset, not distinct. Just wanted to add that.
Thanks, Jeff. So then we go through, we create an admin for the organization scope. We create a read-only role for the organization scope, and then we create a project admin role as well. So basically for the org and project level, at the org level, we have read-only role and we have an admin role. And at the project level, we only have the admin role. In the roles.tf file, you'll notice that we're actually going through and adding the backend and front end users, their principal IDs to the admin, the org admin. We're adding the leadership user or principal IDs to the org read-only. And then for project admin, we're then again adding the backend and front end principal IDs to that role as well. And so that's how we set up the basic administrative and read-only roles and the ability for a user to then access different Boundary resources. So finally, we go through, we add, there's a auth.tf that you'll notice that actually sets up the auth method for password. And then we go and add the different host catalogs and hosts and host sets. Now, this is where we actually inject some values from the AWS deployment. Specifically, we get the IP addresses of the servers that we deployed in that private subnet, and we inject them into the target configuration. And so after we create the different hosts, we then set up a target. I'm sorry, I'm totally backwards on this. So once we set up a host catalog, we add a host and we add the IP address from the EC2 instances in the private subnet. And so that's where we're actually grabbing information from AWS and we're pumping them into the Boundary configuration. This is a really good example of how to set up a dynamic host configuration with Terraform. As those IP addresses change, you could conceivably rerun Terraform again. Eventually in the future here, in not too distant future actually, we're going to have dynamic host catalogs that do this for you under the hood in a running environment. Today we don't have that though, so if you want to do dynamic configuration with Boundary, you can use Terraform to kind of fake it for the time being. So finally, the last thing we put in here are the targets. These are the abstraction that groups hosts together and gives them a port definition. And in this case, we're doing two targets that are both pointed to the backend servers in that private subnet. One is the default port of 22. That's what you're using to do SSH to the target. And the other default port is 8000. And that was for a demonstration that I was giving when we first set this up, running a web server inside of a private subnet and then proxying it with Boundary to a browser on a public-facing laptop. So that was a lot of talking. I'll pass it off back to you, Rob, if you have any other follow-ups there.
Feel free to take a sip of water. You've definitely earned it. I just want to flag up, but we'll post the link to my blog article that I wrote, which kind of breaks down some of the identity and access management components of Boundary there. So that might help give a bit more context to some of the things that Jeff Malnick was talking about. And just on another note, we can call you Malnick here, and we can call the other Jeff Mitchell here, but then in the wider scope of HashiCorp, we can't call you Mitchell because one of our co-founders is called Mitchell, and it's confusing. So
you also can't call me Jeff Mitchell because there are two Jeff Mitchells in HashiCorp.
We can't win. We definitely can't win here. Okay, so we have another question here. So let's check this out.
Can I add one thing to what was said before we go to the question?
Yeah, definitely go
just about what Malnick was saying about the ability to control whether things are created automatically. So this was something when we over time with Vault, we would hear a lot about people that really wanted to control everything in the environment through Terraform. And the reason is that you have, in many cases, you have very good change management functionality already set up for Terraform files. And so, you have, shared configuration files. Those have to go through a GitHub, they get pushed up to GitHub. They go through a pull request workflow that has to get approved by, X number of people and like a repository admin. And then once that happens, it goes and gets triggered to run. And so you already have multiple approvals set up. And so one thing that we really want to strive for is like, in many cases, you want the easy mode, right? You want to be able to say, look, I just want to define like the top level stuff. And if you create other things that make it easier for like things to happen automatically and just sort of like get going, great. But there are also people that they want their Terraform config, because it is infrastructure as code, to actually reflect the system. And so that was something that was sort of complicated to build in, but we did, which is, you can turn off a lot of this automatic creation of, or really everything that's automatically created, you can actually turn off, and you can use Terraform along with the recovery key to create this for you, and where you define everything from soup to nuts. And it is more complicated. It does add to complexity in a real way. But the flip side is, there's no sort of surprise of like, that role was created automatically. Then someone modified it, and I didn't realize what they had modified it to do, because let's say I forgot what, we didn't have a change process in place for that, or I forgot who had access to it. And so this prevents that sort of scenario where you can say, okay, I literally can look through my code and know exactly how the system is set up. So it's, it's up to you as a user, but both kind of methods are supported.
Yeah, I'll definitely echo that. I've worked with so many companies who they want to look at their Git repos and see that as the single source of truth. Whatever it says there will reflect the real environment, especially those that are kind of moving towards a GitOps kind of workflow. It becomes really important. So yeah, it makes sense why that approach was taken. Moving on to our next question. So not sure if this was already asked, but seeding the Boundary agents has a Nomad job anywhere? I'm not quite sure I fully get the context of that question.
So I think here's my guess as to what, I'm also not sure, but I'm going to take a guess. I think there's an assumption being made that on every host you want to connect to, you must have an agent in order to receive that connection. And that is not actually the case. Right now, we are proxying protocols for you. And you can certainly get to a point where you say, okay, the only machines, on each host firewall, I'm going to allow only Boundary workers to have inbound connections coming in. And so that adds defense in depth once you have things behind Boundary. But we don't require an agent on the host at this point in time. And I say at this point in time, but really there are no plans to ever require an agent. It is likely that in the future we will introduce features where if you want to take advantage of this feature, it requires an agent to be installed. But the core functionality is still done within the Boundary controllers and workers or a client. So if you're deploying Boundary right now, you do not need to do anything on every host that you want to gate access to. You can wall off the firewall to just Boundary workers, which is just prudent defense in depth, but it's not it's not required. And so my guess is that they're asking, is there a way in Nomad to is there a Nomad job that will push agents to locations or push agents to all the endpoints? But assuming that I understood the question correctly, the answer is you don't need to do that. And in fact, right now there is no agent, so you can't do that. But we when we were doing kind of market research on this, and we were talking to a lot of our existing Vault customers and other customers about this solution, one thing we heard loud and clear was, please no agents. Everything that we deploy requires yet another agent on the box we have to maintain and install and configure and secure. And so, while there are real, benefits that can be gotten from having agents, we decided to go agentless first to kind of satisfy those needs. And then later on, we can add agent-based features as we develop them.
As a practitioner myself, I just want to say thank you for going agentless. I have been that guy that has to make the case to security as to why this is not increasing the attack surface by having another service running on this box, or we need to patch this to the latest version, and we don't really understand what the changes, the impact the changes are going to have. And it's, managing infrastructure is complicated as it is. So, all these extra pieces, it's, I wouldn't say it's not helpful, but it's another thing that you have to do, right?
Right, and it increases attack surface. I mean, there are, you're trading off sort of installing an agent that is part of a security solution and hoping that is coded right, and hoping that is, that is going to work the way it's anticipated, and that there aren't any kind of flaws that maybe aren't even known by the company but are known by by black hats out there. if you have 100,000 machines, which, I've worked for a company that has at the time 140,000, I'd be surprised if they weren't above 200,000 at this point. If you have 200,000 machines out there, then like if you're installing an agent on every single one of those, then not only is that a lot of traffic, but it's also just like, things get behind. You have to roll upgrades across all those. And you don't know just whether, just what that attack surface is. And so we always wanted to keep it optional. And there will be things that you have to be on the box for fundamentally, but we're just not there yet. And they will always be optional.
And I think also on the subject of Nomad, so Nomad it's just a scheduler. It will schedule jobs, is what we call it in the Nomad world, right? And it goes back to what we were talking about earlier on about the vision of getting dynamic host catalogs. As we know, Nomad has native integration with Console Connect. You can have services automatically register to Console, and then the vision would be to populate these host catalogs with the information that comes from Console. So you can start to see what the bigger picture is going to look like as the months go by. So, or months and years. I don't really want to put a time scale on it, but that's kind of the way I'm seeing it, and that's what I'm getting from the team. Is that's the direction that we want to head in. So no agents.
Yeah, I think that's correct. I mean, Nomad as a scheduler integrating directly with Boundary right now, there aren't a lot of integration points that I think would necessarily make sense. Although there are potentially, because Nomad is actually very flexible, it can do containers or shroots or single binaries or whatever. It is, it's potentially possible that Nomad would, there'd be some kind of Nomad interaction directly with Boundary for the things that aren't necessarily getting registered in Console. On the other hand, because it can register in Console, that's certainly a good sort of first order approximation, is integrate with the service mesh first, because that's your source of truth for services. So that's what we're looking at. And, that's one service mesh, and we're certainly, the fact that it's in-house does not mean it's the only service mesh we're looking at. I'll just put it that way.
Amazing. So a question, it's been mentioned earlier on, and I know we talked about some of the components, but what exactly is dev mode?
So dev mode is our run Boundary locally as easily as possible mode, is what it is in a nutshell. So we actually manage a Docker container for Postgres locally when you run Boundary dev. So it stands up a worker controller, takes care of the configuration of the workers and controllers, sets up essentially all the resources within Boundary that you would need to just log in and, with admin and password. It's all default. For us, while we're developing Boundary, we use it pretty often just to make sure things work as expected. And for end users, it's the entry point in our getting started guide for running Boundary locally and taking it for a test drive.
So this is something that's shared across, I think pretty much all HashiCorp tools have a dev mode. And we found it to be incredibly useful both for us as people that have to, run instances all day as we're developing and testing, but also just for people getting started to test it out. And so with Boundary, 3 commands can get you making your first connection. So Boundary dev, Boundary authenticate, and Boundary connect, right? Like those 3 things are actually enough with the dev mode to make an SSH connection to your local machine. So it really is that simple. And it sort of, because you can then open the UI and sort of browse through and see how things are laid out, it also gives you that ability to see what does a comprehensive single resource but comprehensive end-to-end setup look like in terms of the resources that are created, that all feed into a target that you can make a connect call against.
So to me, as someone who has learned a lot of our tools starting with dev mode is like hello world, right? It gets you up and running and you can try stuff out without the setup complexities. Because let's face it, when you deploy in any clustered solution, clusters can be complicated. So just to abstract away all of that and just get to the core of what the tool is trying to solve, the problem that the tool is trying to solve, that's pretty much what dev mode is. And I've posted the link in the chat for the Getting Started guide that Jeff Malnick mentioned. So definitely check it out and go through some of the tutorials on there and familiarize yourself with how Boundary works. And moving on, so it's a bit of a curious question here. This one's going to Malnick. In terms of the reference architecture, Why AWS?
Well, when we were doing a lot of, when we did our customer research around Boundary, we wanted to understand what clouds are the most commonly used among our existing customer base. And AWS was a clear front runner there. So when we put together the reference architecture, we said, okay, what are the two things that people are probably going to want to do with this on day one? Majority of people, probably existing Vault users, will want to run Boundary on AWS. So we had an example for that. The great thing about that example, though, and that specific reference architecture is that it can essentially be rubber stamped on any other cloud platform. So if you're using Azure or GCP, the primitives in those environments are very similar. The Terraform code changes, obviously, the providers change under the hood, but the underlying abstractions are essentially the same. So it's it's a reference architecture for that, just that reason. It's a reference. So you can rip it off and deploy it on your own platform, whether that's Azure, GCP, Oracle, whatever. It's easily transcribable to those different platforms. The second platform is obviously we wanted a container example of some sort. In lieu of having a real Kubernetes integration on day one, we just went with the Docker Compose example, but we are working on that story. We understand that's an important platform for our end users, and we're really excited about what the future holds there too.
And it won't surprise you to hear that, like multi-cloud is HashiCorp's ethos. In fact, multi-cloud and on-prem, really, right? So many of our tools are really helping you kind of along that entire journey from on-prem to multiple clouds. And I say that because most of the, most larger customers, and we work with a lot of very large customers, their plans right now might be, we're just trying to get on one cloud, but they already know they're going to be multi-cloud in the future because there are just too many reasons. Often it's contractual. Sometimes it's, particular needs or resources that are served there. And so from the beginning with the design, we have two outside requirements for running Boundary. One is Postgres. And in theory, we can support other databases, but we need to select one for now. And the other are KMSs, so some kind of keys that we can use. And one of the reasons that we selected Postgres to start not only is because it's kind of a well-storied, well understood, production ready, open source free database, but it's also widely available on basically every cloud out there. And so you can run it on-prem easily. You can run it in clouds easily. And that makes it really easy to get up and going across pretty much any cloud you could want to run Boundary on, or even on-prem. And the same is true for KMSs. And so, it uses the same underlying libraries that Vault uses for auto unseal if you're a Vault user. So that supports basically the KMSs for pretty much every cloud out there. And it supports Vault itself as Vault's transit engine as a KMS provider as well. And so, whether you're on-prem or whether you're on one cloud or many clouds, you can really run Boundary anywhere. And we've made sure of that from the very beginning. So just echoing, what Malnick said, it is a reference architecture, but it's, the design of Boundary has always been meant to be multi-cloud right from the start.
Is there any guidance on the size of the infrastructure required to run Boundary? So, like machine sizes, storage size, CPU, all that kind of stuff there.
So Jeff Mitchell can speak to this a little bit more, but we don't specify any guidelines right out the gate. It really comes down to what your infrastructure and what your usage is looking like. So if you're managing tens of thousands of sessions, then you're going to need more workers, and those workers are going to need to be on boxes that have enhanced networking and that sort of thing, to make sure that the pipes going to them are big enough to handle that sort of traffic. Sorry, I've got a small technical problem. Jeff, why don't you take this?
Sure, I'll take over. One thing that we actually want to do very large scale benchmarks. We actually have a team that's working on standing up kind of a capability internally to do that. Right now, anecdotally, we aren't running a lot of queries into Postgres. Even as if you're running, a fairly heavy workload, we know that Postgres is capable of doing thousands and thousands of writes a second and millions of reads depending on your hardware, and we aren't doing anything near that. So, I think at the moment we sort of don't have particular guidance, but we also don't think it's going to be, we don't anticipate people needing a lot of resources to run it at the moment. It's not, for kind of a comparison, if you're doing encryption as a service through Vault, you might be like, I want to be able to chuck, 10,000 requests per second, per node through Vault. Generally speaking, we don't think that most usage patterns are going to be 10,000 requests a second. It's going to be, I'm a human user, and every few hours, I connect to another machine, which maybe means a couple of calls into the database. So, so I think that this is, I don't think it requires a lot. We will have better ideas and guidance as we build out that benchmarking capability in the future. And the other thing I was going to say around that is, I had something at the tip of my tongue. There's also just places where we know we can optimize that we haven't yet. So there are places where we know we can reduce some calls to the database that are a bit redundant, things like that, where actually over time we can make it more efficient. So, I think it's just a little bit too early to have a lot of guidance, but I wouldn't expect a lot of resource utilization. We can look at like dev mode, for instance, and that's running real Postgres in a Docker container, and it's, and real binaries, and it's not high.
Amazing. Okay, so that brings us towards the end of this deep dive session. So I want to thank you both for joining us. Just to give a shout out there, we have more deep dive sessions planned. So I'll actually be on a Vault deep dive session, which I believe is next week, Tuesday. But if you go to discuss.hashicorp.com, we'll have all of the deep dive sessions in there. So definitely check that out. And with that, I will leave you and say thank you very much for joining us. Thank you to our guests, and we'll catch you on the next one.
Thanks for having us.
Cheers.